This video tutorial will help you complete the homework for week 7. Let's start with the questions in the Monday box. This is a review of solving equations with distributing, combining like terms, and variables on both sides. You'll notice in question number 1 that the right-hand side of the equation has 3 terms: 8x, minus 5, and plus 2x. When you have more than 2 unlike terms on a side, you have to use combining like terms in order to shorten it. We will not use an inverse operation. We will use the operation that is stated next to the terms we're going to combine. So we have 8x's and we want to add 2x's to that. So 8x's plus 2x's make 10x. The minus 5 remains the same, and the entire left side of the equation remains the same. Now that both of my sides only have 2 unlike terms, I can use inverse operations to move the pieces together. I cannot combine terms that are on different sides of the equal sign. So I have to do either plus 6x to both sides or minus 10x to both sides. Both of those choices would work, but I'm going to choose to add 6x to both sides so that my x stays positive. My 2 remains the same, my equal sign stays here, and my x becomes a 16. Now I need to get my constant terms together, so I'm going to add 5 to both sides. This is an inverse, which will give me a 0, and when I rewrite both sides, I have a 7 on the left and a 16x on the right. To finish this problem, I'm going to divide both sides by the coefficient, which is 16. If your division problem is not in a whole number or an integer, then you can leave it in fraction form. 7 divided by 16 is not that long of a decimal. It would be 0.4375. But you can always leave your fraction just as it is here, like this. So 7/16 would be an acceptable answer, and so would the decimal 0.4375. Now, if it was a decimal that kept on going and going and going, I wouldn't write it in decimal form. I would leave it as a fraction. All right, let's take a look at question number 2. Question number 2 has a denominator and a constant. The denominator here of dividing by 5, I'm going to leave until the last thing. So I'm going to add 7 to both sides of my equation to clear this constant away. Negative 3 plus 7 is positive 4. So the inverse here for my final step would be the opposite of x divided by 5, which would be to multiply both sides by 5. I'm going to use parentheses to show that multiplication. 5 times x is 5x. 5x divided by 5 is 1. So I'm going to leave that 1 invisible and just write my x all by itself. 4 times 5 is 20, and that's the final answer. For question number 3, we have parentheses, so we need to distribute here. 1.2 times x is 1.2x. And 1.2 times 2 is 2.4, positive 2.4. The right side of the sentence remains the same. Okay, my left-hand side has more pieces, right? More terms, 1.2x, and my constant term of 2.4. My right-hand side only has a variable term. So I'm going to move this variable term over to the other side by using an inverse operation. Oops. This becomes a 0, and my 2.4 remains the same, and over here I'm going to get negative 2.4x. So now for my final inverse operation, division, and notice that I use the negative sign as well. It is a negative 2.4 coefficient, so I divide by a negative 2.4 coefficient. And negative 1 is my final answer. Okay, let's take a look at the next two. Question number 4 has a bunch of fractions in it, but it looks like these fractions have like denominators, so it's not going to be that difficult. The x's, however, are not on the same side. So I'm going to choose to subtract one of them, and I'm going to subtract this one because it is the smaller variable, and this way my coefficient will remain positive. I bring down the minus, I bring down the 15, and I bring down the equal sign. 6/5 take away 3/5 is 3/5 x plus 12. Now I can move my constant of 12 over to the answer side here by subtracting 12 from both sides. This is an additive inverse, so it becomes 0, and negative 15 combined with negative 12 makes a negative 27. Now technically the inverse here of multiplying by 3/5 would be dividing by 3/5, but we don't typically divide by a fraction. So what we do instead of dividing by 3/5 is we show that dividing by a fraction really means to multiply by the reciprocal, or multiplying by 5/3. So you can certainly use a calculator here, but timesing by 3 and dividing by 3 are inverses, and timesing by 5 and dividing by 5 are inverses. And that's why my x, right, has an invisible 1 coefficient. 3 divided by 3 is 1, 5 divided by 5 is 1, but I'm going to leave that 1 off. These are called multiplicative inverses. Now over here you can do 5 times negative 27 first, or you can do negative 27 divided by 3 first. So negative 27 divided by 3 is negative 9, and negative 9 times 5 is negative 45. Or you could use the fraction button on your calculator to do 5/3 times negative 27. Okay, the last question has parentheses on both sides, so I'm going to distribute twice here and get 20 minus 12x, and I'm going to distribute twice over here. Now watch my signs carefully. Negative 2 times 6x is negative 12x, but a negative 2 times a minus 10 is a positive 20. Be very careful here. This side has 2 terms, the right side has 2 terms, so I have 4 choices of where I want to start. I'm going to choose to start with my variable so that if it disappears and becomes one of my special answers like infinite solutions or no solutions, I can find out right away. So I'm going to choose to add 12x to both sides. And it looks like when I do that, I get a cancellation, a 0 here and a 0 there. So let's rewrite what's left and see if it's a true sentence or not. So if the numbers here are equal, if the left side and the right side are a perfect match, we call that infinite solutions. If it had said something like negative 20 equals 4, we would say that was no possible solutions. Okay, let's take a look at the second box. Identify the rate of change, that's another word for slope. Identify the rate of change and the y-intercept from the given linear equations. Now remember, the rate of change when you're looking at a linear equation is the number that's in this m position. That's the rate of change, or the slope. The number that's in this b position, that's the y-intercept number. So the number in the m position is the slope, or the rate of change. The number in the b position is the y-intercept. And even if I change the order, this is still the slope, this is still the y-intercept. The slope is the coefficient, the y-intercept is the constant. So don't be tricked if I change the order. So question number 6 asks you to identify the slope and the y-intercept, and when I look at my sentence, the slope is the coefficient of x, which is right here. So the slope for number 6 is actually negative 2. Don't write the letter x. X is not the slope. The number is the slope. So now that we found the coefficient of x, we know the slope. The constant in the sentence is the y-intercept. Positive 5 is the y-intercept, minus 2 or negative 2 is the slope. Now with question number 7, you might get tricked into thinking that the rate of change is 12, but unfortunately it's not in y equals form. You'll notice that y equals form means that the y is alone, but in our example here the y has a 3 as a coefficient. So I have to get rid of this coefficient before I can even start. And in order to get rid of a multiplication, I use division. So the real sentence is y equals 4x minus 7. That's the real sentence, not this one. So the slope or rate of change here is positive 4, and the y-intercept is minus or negative 7. You'll notice the same thing with question number 5. You can only tell the rate of change by looking at the sentence if the y is all by itself. And if the y is not all by itself, you need to use inverse operations to get it isolated. So the opposite of multiplying by 5 is dividing by 5. So I'm going to divide all of these terms by 5, and if it doesn't come out to an integer or a whole number, I'm going to leave it in fraction form. And that's okay, because you're going to find out pretty soon that we actually like when our rate of change is a fraction. So the rate of change, or the slope, is the coefficient of x. It's not the letter x, it's just the coefficient, the number that's multiplying it. So the rate of change here is 2/5. And the y-intercept is minus 3 or negative 3. If I ask you to describe in words how to find the y-intercept when all you're given is the linear equation, so here we go. If we have this linear equation, y equals 4x minus 7, how would you describe to someone which one of those numbers is the y-intercept? You would have to use some type of vocabulary word that differentiates these numbers from each other, right? This number is multiplying x, and this number is not. So even though I know it's tempting to say the number before the x or after the x or timesing the x, I want you to use one of our grade level vocabulary words. So for this, you can identify the y-intercept as the constant in the y equals sentence. So describe in words how to find the y-intercept when all you are given is the equation. If the equation is in y equals mx plus b form, the y-intercept is the constant, right? That's the number with no variable, is the constant in the b position, if you want to be more specific about exactly where it is in the formula. Okay? Sometimes the b position is at the end, sometimes the b position is at the beginning. So since it's not always in the same place, you can't say it's the first number or it's the second number. Right? So you have to be very specific that it is the constant in the y equals mx plus b equation. All right, for questions 9, 10, and 11, I ask you to write the y equals mx plus b equation using these specific values. So remember, the slope is the number in the m position. That's the slope. And the number in the constant position, that's the y-intercept. So for my equation for number 9, I would write y equals a 2 in the m position. And since the y-intercept is minus 4, that's what I write. Now be careful here. I gave you the number negative 5 first, but that's the y-intercept. And the y-intercept is the number that goes here, right? The number that goes at the end after the coefficient. So minus 5 is the y-intercept, and the slope is 7. So y equals 7x minus 5. And the last one here would be y equals negative 2/5 times x minus 6. Okay, let's review our first quadrant graphs again. Construct and label a line graph. So that is a straight line graph. Construct and label a line graph from the data table. So the first value, our independent value, is time. So we're going to write that label down here. And our dependent value, right, the number of people in the stadium depends on how much time you've been counting for. So our dependent is going to be people in the stadium. So we're going to write that along the y-axis here. People in stadium. Now the tricky part about creating this quadrant graph is that you need to choose an appropriate scale, and it has to be consistent. I can't just copy the numbers and go 5, 10, 15, 25. I have to be consistent with the number of boxes I use. So it looks like I need to go up to 25. So let's see, 5, 10, 15, 20, 25. That would work, but it's kind of all squished up here. So maybe let's see if I can go by 2 boxes at a time. 5, 10, 15, 20, 25. That would work. And it's kind of more spread out. Let's see. 400, 800, 1200, 2000, 4, 8, 12, 20. These look like multiples of 4. So I think I'm going to go with 400s. I wonder if I could do it with 3 boxes. So 1, 2, 3, 400, 1, 2, 3, 800, 1, 2, 3, 1200, 1, 2, 3, 1600, 1, 2, 3, and I ran out of boxes. So I can't go by 3s. So let's try again. How about 2 boxes? 400, 800, whoops, started to go by 3s again. 1200, 1600. I know it's not in the chart, but it is consistent with my scale. 1600 and 400 more is 2000. All right, let's start graphing. 5 is my x coordinate, 400 is my y coordinate. So let's see, I would get 5 and 400, 10 and 800, 15 and 1200, and then 25, so I'm skipping here because it's not in the table, 25 and 2000. And if I did it correctly, it should make a nice straight line. So I'm going to make a title here for my graph, number of people in stadium over time, right? Over how much time they're there. All right, let's take a look at our final box here. We talked about the 4 different types of slope in class today. So it looks like we have some different examples of the types of slope you can have. Remember, you can have an uphill positive slope, which is not shown in these examples. You can have a downhill negative slope. You can have a horizontal 0 slope, right? Remember this? It makes the Z, right? You can have a horizontal 0 slope, or you can have a vertical undefined slope, right? We talked about it making that U shape. You see that? That's a really good visual to help you remember if it is a 0 or undefined slope. Now the question actually is asking you to match it to an equation. So let's remember, if you have 2 letters, if you have a y and an x, you have a line with a tilt, right? If you have 2 variables, you have a tilt. But if your sentence only has 1 variable, like let's say this one, or this one, or this one, then you have one of those special lines, okay? So this equation has to have 2 letters. These equations should have only 1 variable. So let's take a look at question number 13. When I read the graph from left to right, it's going downhill. So that means that since it has a tilt, it has 2 letters, so this is out. It's not even a possibility. And as I'm reading, if I know the line goes downhill, that means it has to have a negative slope, or it has to have a negative x, which means this one's out. So the answer would be B. For question 14, my line is a special horizontal line, which means I can only have 1 variable. So this is out because it has 2 variables. So the question is this a 0 slope where yes, I could ski on it, but it is 0 fun? Or is it an undefined slope, right? Where slope dude falls off the cliff because he shouldn't have been skiing on that. So this one here, yes, I could ski on it. Yes, Y for yes, I could ski on it. But it would be 0 fun because there are 0 x's in this sentence. If there are 0 x's, then you have a 0 slope, which is what this is, right? This is a 0 slope. So if you have a 0 slope, you have 0 x's, so that means this is out. And you'll notice the graph passes through at -1. And the only axis it touches is the y-axis. So if you have a y in your sentence, you have to touch the y-axis. And this one happens to touch at -1. For question number 15, this is a special line, right? It is vertical or undefined. An undefined line has only one variable, so this is out. You could not ski on this line. So we could not say yes, right? Y is for yes, I could ski on it. So if you cannot ski on it, then this is out. You'll notice that this line touches at -3, and it touches only the x-axis. So therefore, the answer has got to be B. I hope this tutorial helped you complete homework number 7.